Good morning, welcome to SAKALAVIDYA YouTube channel. Okay, welcome you all. In the morning session, we have discussed up to 55 problems on permutations and permutations only. Today we shall continue some problems. Okay, welcome all of you once again. So let us start directly because actually in the evening session we have only 1 hour session, so that there may not be actually any directly. We shall switch over to the problems. Thank you. Right. Fifty-sixth problem. 56th problem. Fine. A letter lock consists of three rings, each marked with 10 different letters. 10 different letters. Number of ways to make an unsuccessful attempts to open the lock is to open the lock is first option 899, second option 999, third option 479, fourth option 568. This is the problem. Okay, right, let us see. A letter lock consists of three rings, each marked with 10 different letters. The number of ways of unsuccessful attempts to open the lock. That means actually here we have three locks. First lock, second lock and third lock. It's numbered from 1, 2, 3 and dash dash 10. This also 1, 2, dash dash 10. 1, 2, 3, 4 dash dash 10. That means this can be turned 10 ways. This can be turned 10 ways. This can be turned 10 ways. But out of actually here, the total number of ways is equal to 10 into 10 into 10. But out of this 10 into 10 into 10, we have only one successful attempt to open the lock. But we are asked unsuccessful attempts. That means total number of attempts minus successful attempt. So one that need to be subtracted. So that means we get now number of unsuccessful attempts to be made equals to total number total number of attempts minus 1 successful attempt. This is actually 10 cube minus 1, because this can be done 10 into 10 into 10. This equal to 10 cube, whose value is 1000. So 1000 minus 1, that is 999. That means second option is the right option. Second option is the right option. Okay, understood now? I hope everybody will understand this one. Right. Fifty-seven. The number of four digit telephone numbers having at least one their digits repeated is one condition. Zero can be accepted in the first place. Okay, first option 50-40, second option 4960, 2520, third option, that is fourth option is 2480. That means even 0 may be accepted in the first place, but in general actually if you just put the 0, that cannot be the 4-digit number, but here that can be accepted. But here you see the 4-digit telephone numbers need to be formed now. 1, 2, 3, 4. So that means actually one condition here. At least means total number of permutations or total number of arrangements with a repetition minus total number of arrangements without repetition we need to find out. So that means actually here see, with repetition is this is actually here total we have the digits. Actually here we have 0 to 9 digits, total 10 digits. This can be placed 10 ways, that is 10 to the power of 4, right? 10 to the power of 4 is equal to 10,000. So next, second one is with repetition, without repetition is 10p4. So 4 places are to be filled with 10p4. That is 10 into 4 in 10 into 9 into 8 into 7. That is 70 into 72. 14. Okay. 504 0 50 40. So that means we can write like this now. Therefore, required number of telephone numbers is equal to total number of arrangements with repetition with repetition with repetition minus total number of arrangements without repetition that is equal to 10 to the power of 4 minus 10p4 that is equal to 10,000 minus 5040. So that means you will be getting, actually, if you subtract 5040 from 10,000, what do you get now? 4960. You can check it now. 4960. Second option is the correct option. Second option, option 2. Very good. Wonderful. Good job. Right. $58. The number of quadratic expressions with the coefficients with the coefficients drawn from the set 0, 1, 2, 3 is right. First option is 27, second option is 36, third option is 48, fourth option is 64. This is the question. So this is very, very important. No problem. Whenever you join, that's your wish. No problem. So 58 is very important question. 58. See, the number of quadratic expressions with the coefficients are drawn from the set 0, 1, 2, 3. 0, 1, 2, 3. First solution, you see, let the quadratic expression be, f of x equals to ax square plus bx plus c. According to the definition of the quadratic expression itself only, is the general form of the quadratic expression, providing the condition a does not equal to 0. A should not be equal to 0. Except 0, any value may take. This a is called x square coefficient, b is called x coefficient, c is constant term. B can be 0, c can be 0, but a should not be 0. If a is 0, it is not a quadratic expression. It becomes linear polynomial. Understood now? Whose degree is 1. So that's why now we need to do like this now. That means we need to select A, B, C from this set. How can you select? A, B, C need to be selected. So A can be selected, 0 should not be there, 3 ways. Whereas B can be selected maybe 0, 1, 2, 3, 4 ways. C can be selected also 4 ways. That means, therefore, required number of quadratic expressions equals to number of ways of filling three places here from four elements with repetition. With repetition means actually one condition, possessing one condition. First place should not contain 0. So that means this can be written now 3 into 4 into 4. That is 3 times 16. So you get 48. So third option is the right option. This is very, very important. This question is very, very, very important. You remember this one. That means we can frame 48 quadratic expressions with the help of the set 0, 1, 2, 3, providing by giving the different values for a, b, c, but provided a does not equal to 0. That condition we need to keep in mind. Okay. (59) Number of different matrices yes, repetition is allowed, Soma. So repetition is allowed. So here in these cases repetition is allowed. For quadratic equations, for matrices, repetition is allowed. Absolutely. As many as number of different matrices that can be formed here, don't get confusion. Different matrices means different types of orders of the matrices. Yes, no problem. Same coefficients, no problem. But except x square plus x plus 1, all coefficients are equal. 1, 1, 1, 1. It may not be given, but we need to understand like that. But particularly in these problems, we need to remember. But rest of the thing is, whenever repetition is not given, that we need to consider as without repetition itself only. So number of different matrices can be formed with elements 0, 1, 2 and 3 each matrix having four elements is first option 3 times 2 raised to 4, second option 2 times 4 raised to 4, third option 3 raised to 4 power 4, fourth option 4 raised to 4. Okay, right. Number of different matrices, that means different types of matrices that can be formed with the elements 0, 1, 2 and 3, each matrix having 4 elements. Here also we can make use of the 0. 0 is accepted, but actually what now 4 elements? 4 elements means we can write like, for example, 4 elements, let us write factors of 4. 1 times 4 and 2 times 2 and 4 times 1. That means we can frame 1 by 4 order, 2 by 2 order, 4 by 4 order. That means 3 ways we can find out the matrices. 3 orders, 3 different orders we can frame it now. So for example, say 1 by 4. 1 by 4 means the matrix will be like this. First type will be like this. 0, 1, 2, 3. 4 places here. This is 1 by 4. Next we can form 2 by 2. 0, 1, 2, 3. This is 2 by 2. Example I am considering. So next column matrix 0, 1, 2, 3. These are the possible ways we can form it. But 0, 1, 2, 3. In the place of 0, 0 may come, 1 may come, 2 may come, 3 may come. That means this can be, you just observe it. So this can be filled 4 ways, this can be filled 4 ways, this can be filled 4 ways, this can be filled 4 ways. In the similar manner, this is 4 ways, 4 ways. That means this can be 1 by 4 matrices can be 4 to the power of 4. Even 2 by 2 matrices also 4 to the power of 4. Even 4 by 4, 4 by 1 also 4 to the power of 4. Total we need to add. This is case 1, case 2, case 3. So that means 4 to the power of 4 plus 4 to the power of 4 plus 4 to the power of 4 equal to 3 times 4 to the power of 4. So that means now we can write required number of different matrices, means different types of matrices, equal to 4 to the power of 4 plus 4 to the power of 4 plus 4 to the power of 4. Total we get 3 times 4 to the power of 4. That means third option is the right option. Third option is the right option. This is also important problem. Please, in the case of 58 and 59, even though it is not given without repetition, we need to consider with these are special problems, but we need to concentrate. Rest of the problems, whenever mentioned repetition, you need to select the repetition itself only. Problem number 60. The number of numbers less than 2000 less than 2000 that can be formed using the digits using the digits 1, 2, 3, 4. When repetition is allowed, your condition is imposed. When repetition is allowed, is first option is 84, second option is 148, third option is 180, fourth option is 1440. This is the question. Okay, right. What is the answer, Mr. Rakesh Kumar? Now, even though IPE problem, what is the answer? Okay, I will wait till completion of your answer. What is the answer? Vinila Bhavanam, 148. Okay. How did you get 148? Could you support? Do you justify your answer? Right. The number of numbers less than 2000 can be formed using the digits 1, 2, 3, 4 with when repetition is allowed. Repetition is allowed. Less than 2000 means we have even 4-digit numbers, 3-digit numbers, 2-digit numbers and 1-digit numbers. That we need to find out. So that means first we need to find out like this: 1-digit number, 2-digit number and 3-digit number, but don't find out all 4-digit numbers, because if you find all 4-digit numbers, means what happens means even the digits which begin with 3 will come, the digits which begin with 4 will come. That means they are more than 2000. So that means in order to restrict less than 2000, first we need to find out like this: 1-digit numbers when repetition allowed, 2-digit numbers, 3-digit numbers, and the 4-digit numbers which begin with 1 we need to find out. That's all. So that will be the answer. So let us do it now. So less than, we need to find out less than 2000. This is an important condition, need to remember. First 1-digit numbers. 1-digit numbers. 1-digit numbers means 4 only. Obviously 4. That's all. No chance. 2-digit numbers. 2-digit. 2-digit means repetition is allowed. 2 places. 2 places means actually you will be getting 4 square. 4 square. So that will be 16. Next 3-digit numbers. So 3-digit numbers is equal to 3 places. 3 places with 4. Repetition is allowed. It's important thing. 4 into 4 into 4. 4 cube. That will be 64. So this equal to 4. Next, don't write the 4-digit number, because this condition is important. We need to keep in mind. So that means 4-digit, but here you remember the condition, begin with 1, 1, 2, 3 places. So the 3 places can be filled in 4 cube ways, 64. Total we need to add, that's all. So therefore now required numbers less than 2000 equals to 4 plus 16 plus 64 plus 64. 16 plus 4 is 28. 64 plus 64 is 128. Now 128 plus 28. Okay. Right, something I did mistake here. Now I need to check now. Option 2 is okay. 4. This is 4 square 16. 4 cube is 64. 64. Okay, this will be 20. Sorry. I did mistake here. So now 16 plus 4 is 20. 20, you get 148. So this equal to 148. Answer is there? Yes, absolutely. Second option. Second option is the correct option. Okay, you are better than me. You are good at calculation. Understood? I hope you understood this problem now. Next 61 problem. 61. 4 dice are rolled then the possible number of possible outcomes in which at least one dice shows 2 is first option 1296, second option 625, third option 615, fourth option 671. Right. This is actually useful for even probability chapter also, this question. 4 dice are rolled, then the total number of possible outcomes is what? 6 into 6 into 6. Even without repetition is given, generally we need to consider the 6 into 6 into 6, 4 times means 6 to the power of 4. But what condition is given? At least one dice shows 2. Shows 2 means, for example, keep 2 on the one of the faces. Now remaining 5 faces can be filled. How many ways that can be done? Remaining on 4 dice means 5 into 5 into 5. 5 ways. So that's why 5 to the power of 4. The possible outcomes, at least one dice shows 2 is equal to total number of possible outcomes minus the number of possible outcomes all dice shows 2. So that we need to do it now. Right, let us write now. So that means solution. At least one dice shows 2. Required number of ways is equal to total outcomes when 4 dice are rolled minus the number of outcomes 2 should not come. Okay, 2 should not appear. So that means 2 should not appear means we need to consider only 5. The total outcomes is actually 6 into 6 into 6 into 6. So 2 is kept aside and 4 dice 5, only 5 cases. 1, 3, 4, 5, 6, that's all. So 5, 5. This we can write 6 to the power of 4 minus 5 to the power of 4. What is 6 to the power of 4? 36 into 36. How much you will be getting? So that will be 36 into 36, 1296 minus 5 to the power of 4. 5 to the power of 4 is 625. 1296 minus 625 means 6 minus 5, 1, 7, 6, 671. So answer is 671. 671. Yes. 6 to the power of 4 minus 6p4 is also correct. You will be getting correct answer. Okay. But in general we do like this also. Sixty-two. Total number of four digit odd numbers that can be formed. The total number of 4-digit odd numbers that can be formed using 0, 1, 2, 3, 5, 7 when repetition is allowed when repetition is allowed. The first one 216, second one 375, third one 400, fourth one 720. Here the total number of 4-digit odd numbers, this is a keyword, odd numbers can be formed 0, 1, 2, 3, 5, 7 when repetition allowed is. Then we need to find out. But 4-digit means 0. If 0 comes in the first place, that is not a 4-digit number. But that means we get the two cases here. You need to remember. That means first place, second place, third place, fourth place. How many actually here we have? 1, 2, 3, 4, 5, 6, 7. This is 7 ways, 7 ways, 7 ways, 7 ways. This will be 7 to the power of 4. This without any restriction. For example, say thing 0 is placed in the first place, 1, 2, 3. Now how many we have? So now, sorry, absolutely sorry, I didn't see the keyword. Keyword is very important. Right now. So yes, this is the keyword we have. We need to remember odd numbers. Odd numbers means the last place should be filled with 0, 3, 5, 7. So this can be filled 4 ways, always last place. Here also 4 ways. But after filling 4 ways, this can be filled 7 ways, 7 ways, 7 ways. This will be 7 cube. Now already 2 are filled. That means 0 is filled and next one member will be filled. So that means actually we are left with this is 3 plus 3, 6. 6 minus 2 is 4. So this can be, wait now, 1, 2. 1, 2, 3, 4, 5. 3 plus 3, 6. Okay. Repetition is allowed. Okay. Repetition is allowed means we can write like this. Repetition is allowed means 3 plus 3. Sorry. I did mistake. One minute. So now I will check. Once again I will check. 1, 2, 3, 4, 5, 6. Sorry, 6 ways only. 6, 6, 6. So that means this can be filled 4 into 6 cube ways. Okay, now this can be filled 6, 6. So this is 4 times 6 square. But these are not actually 3-digit number. From this we need to subtract this one, 4 into 6 square. So that means here see, required 4-digit numbers equals to 4 into 6 cube minus 4 times 6 square. Take 4 into 6 square common. We get 6 minus 1. That means 4 into 36 into 5. So 20 into 36 equal to 720. So fourth option is the right option. Fourth option is the right option. Right. 4 into 6 into 6 minus 4 into 6 into 6. Okay, option 4. Everybody is correct. Wonderful, wonderful, wonderful. Sixty-three. Number of numbers greater than 1000 but less than 4000 that can be formed by using the digits using the digits 0 1 2 3 4 with repetition is first option 105, second option 125, third option 375, fourth option 625. So here condition is there. What is the condition? Number of numbers greater than 1000, but it should be less than 4000. Greater than 1000 and next lesser than 4000. So that can be formed by using 0 1 2 3 4 with repetition. This condition is there with repetition. So that means what we need to find out now? Greater than 1000 means we need to find out the 4-digit numbers. Begin with 1 we need to find out. Begin with, because 1 is there, 2 is there, 3 is there. Less than 4 means simply begin with 1, begin with 2, begin with 3, just find out. So that lies in between 1000 to 4000 itself only. Understood now? So that means now we need to make a plan like this. 4-digit number begin with 1, 1, 2, 3 places. These 3 places with repetition. With repetition means how many are actually here now? 1, 2, 3, 4, 5. That can be filled 5 cube ways. Begin with 2. Here also 3 places. That can be done 5 cube. Begin with 3. So that's also 5 cube. So we need to add 125 plus 125 plus 125. 125 into 3. That will be 375. So this third option is the right option. So solution, required number of ways is equal to required numbers equal to 5 cube plus 5 cube plus 5 cube, or 3 times 5 cube, 3 times 125. So 3 5 ja 15, 375. So this is the right option. Okay, 63rd, with the repetition itself only. So that means actually the number must lie between 1000 to 4000. That means greater than 1000 and less than 4000. Greater than 1000 means you can take like this. So start with 1, start with 2, start with 3. That's all. Don't write start with 4 because we should not require more than 4000. Less than 4000 itself only. So but 0 cannot be in all three places. Yes, 0 may be placed, no problem. No problem. 0 can be placed. For example, 10 something 30. This is greater than 100 itself only. Understood now? Right. Sixty-fourth. Okay. 64. 64. Wait now, 5 cube, 125, 125, 250. No, 64th without repetition. Okay, I will check once again. I will check. Okay, 64th. The number of ways in which 5 boys and 4 girls sit around a circular table. A circular table. So that no two girls sit together is. Okay, so I will discuss later. First one, 5 factorial times 4 factorial. Second one, 5 factorial times 3 factorial. Third, 5 factorial. Fourth, 4 factorial. So now this question is related to the circular permutations. So the number of ways in which 5 boys and 4 girls sit around a circular table so that no two girls sit together. There is a condition imposed on the girls. So first There is no restriction for the boys. Let the boys, 5 boys, be arranged around the circle in 4 factorial ways. But among girls, among the boys, how many blank places are there? Within the blank places, we need to accommodate 4 girls. That can be done how many ways? Let us see now. So that means now here this is circular path, understood now. So now we need to arrange first 5 boys. Boy 1, boy 2, boy 3, boy 4, boy 5. This is first boy, second boy, third boy, fourth boy, fifth boy. So this can be 5 minus 1 factorial. This we know. This is 4 factorial. Now how many places are there? 1, 2, 3, 4, 5. 5 places. These 5 blank places are to be filled with 4 girls. That can be done 5p4. 4 factorial into 5p4 is the answer. So let us write it now. Five boys can be arranged around a circle in 5 minus 1 equals to factorial is equal to 4 factorial. This is first task. Now 5 blank places are to be seated, are to be accommodated with 4 girls in 5p4. 5p4 means 5 factorial by 5 minus 4, 1 factorial, that is equal to 5 factorial. Therefore required number of ways is equal to, this is the first work, this is the second work. Using multiplication theorem, this we can write 4 factorial times 5 factorial. That's why first option is the right option. 5 factorial times 4 factorial is same as 4 factorial times 5 factorial. No problem. Option 1 is the right option. Sixty-fifth question. So this question is meant for you. You need to explain. Okay, once I will explain 5p4. Here see 5p4 means, here how many blank places? You check it now here. 1, 2, 3, 4, 5 blank places. Because no 2 girls come together. Here boy, girl, boy, girl, boy, girl means these cross places means blank places. These are blank places. 5 blank places should be filled with 4 girls. That can be done 5p4 ways. So that's why I have written 5p4. So 5p4 is also equal to 5p4 formula 5 factorial upon by 5 minus 4 factorial. That is equal to 5 factorial by 1 factorial. So that is 5 factorial. Okay. Sixty-fifth problem. Okay, I will check now. Yes, 5p4 is no. Here I write 5 minus 1 factorial is equal to 4 factorial. After that I have written 5p4. This is a different. No, this is equal to 5 minus 1 factorial is equal to 4 factorial. Next, this can be done 5p4. This is the first task. This is the second task. That in rough part I have done. Okay, no problem. 65 the number of ways of arranging 8 men and 4 women around a circle such that no two women sit together side by side. Sit together is first of all 8 factorial, second one is 4 factorial, third one is 8 factorial times 4 factorial, fourth one is 7 factorial times 8p4. Oh, wonderful, wonderful. Prasanna, Vinila. Right. Vaibhav, Vamshi Krishna. Wonderful, wonderful. So that means actually the number of ways of arranging 8 men, 4 women around a circle, no 2 women. There is a condition on the women but not on men. First 8 men can be arranged. Directly we can write answer, solution. So this is a circle. First we need to arrange 8 men. 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8. Now gaps 1, 2, 3, 4, 5, 6, 7, 8. So that means first actually you remember now this 8 men can be arranged 8 minus 1 factorial. So that is equal to 7 factorial. Second, now 8 blank places are to be accommodated with 4 women. So that can be done 8p4. So 7 factorial into 8p4 is the answer. Rank of a brother, rank of a teacher. You find and tell me the answer. Gajjala Vishnu. So 8 men can be arranged around a circle in 8 minus 1 factorial equal to 7 factorial. Now 8 blank places are to be accommodated as per condition, accommodated with 4 women in 8p4 ways. Okay, therefore required number of ways is equal to 7 factorial times 8p4. This is our answer. So that means fourth option is the right option. Okay, Suman, tomorrow I shall discuss the rank of the problems, repetition allowed. That I will discuss tomorrow. Okay, now I give one question, all of you give your answer now. I will check your progress now. Right. The number of ways of arranging 9 persons around a circle if there are two other persons between two particular persons is. This is the question. Right. So I cannot buy iPad. I cannot bear that much. So this is a free classes. How could I get the amount? I can't get it. That may cost more than 1 lakh. Okay. First option 2 multiplied by 7 factorial, and second option 3 times 7 factorial, and third one 9 times 8p2, fourth option 4 times 7 factorial. Okay, Krishnaveni, definitely morning I told you, isn't it now? After completion of the our syllabus, definitely I will discuss mock test. Mock test means including previous questions also. Okay, Mahendra, I will show my money that may not be actually offered for what you said is Ila Mahendra. So I will give the clarification to you. You can check, but that amount may not be for. I need to pay even electricity bill also. Last month I received the electricity bill more than 7,000. So next extra for net bill, who will pay net bill? I upgraded the net bill. These problems you cannot understand. Simply you can say that YouTube, see, for educational channels, actually only for fashion. I request you, all of you, even some teachers might be watching this my program now presently, live streaming. Teachers or lecturers now, even my co-YouTubers also might be watching this one. I'll give one clarification regarding these classes, educational YouTube channels. The educational YouTube channels will get less amount rather than entertainment other channel. That's why those who are interested to get money, to earn money, better don't start educational channel. Please, that is my advice, kind advice. You go for entertainments or blogs or even cooking or etc., fashion, or you go like that. But don't start a educational channel. If you want to start educational YouTube channel or only come service purpose, if you have the passion in teaching, then you are welcome to start YouTube channels. Even you can watch through the YouTube also, you will be getting that idea. Nobody will suggest you to start educational channel. This is my passion, that's all I started. I hope you will understand my mission. Okay, thank you. Tomorrow I shall continue this question onwards, because this is not a right time, because 8:30 now. We shall make a move. Thank you, Vanada. But I need to clarify all these things, unless you may have some sort of other thinking about ourselves. Okay, right. Thank you, Vanada. Bye. See you. Just solve this problem. This is actually a task for you. This is a task for you. Just you try this question.